Hey everybody, today we're going to be looking at 4.4, which is solving radical equations. So before, when we had some problems, what we did, remember if we had something like x plus 3 to the fifth equals 32, right? We could solve this by taking a fifth root of both sides, and then that canceled these out for us. It was really nice because it worked nicely for us. And then I had x plus 3, and then this turns into 2, and then I have minus 3, and I get x equals negative 1. So this worked really nice for us. It wasn't too bad of a section. So now the idea for today, though, is we want to go the other direction. If I have a radical x minus 5, and we'll say to the third root equal to something, let's just say 3, how would I solve this? And what we're going to find today is that it works very similar to what we did last time, where we took a radical to cancel out an exponent. We're just going to take an exponent in this case to cancel out a radical. So again, not too bad of a section, especially if you were okay with 4.1 and when you were solving those equations. The nice thing here too is that we don't really usually get two answers. It's pretty rare. The one thing we do need to be careful of, though, is that we are getting real solutions and solutions that work. So that's the one caveat of this section, is that we do need to check our answers by plugging in. So just working through a couple of these. Excuse me. That's just mentioned. So for these ones, again, if you want to take the time real quick and just graph these in Desmos, and then for all these zeros, you're just going to put a y. And when you graph those in Desmos, you're going to find that they match up with these functions. Okay, so the idea is on these, as far as steps go, is we want to isolate the radical. We want to try to get the radical by itself. Okay, now these are for if I have one radical. We'll look at some later where we have two, but those are actually the easy ones, believe it or not. It's the ones where we have one where we have to do a couple extra steps. So the idea here is we want to get that radical by itself. Without it by itself, we really can't do too much to it. I see that I have a square root here, and eventually I am going to want to square that and cancel it out, but I need to get it by itself first. So to do that, I've got this 2 out front, so let me just rewrite this real quick. I've got that 2 out front that needs to go away. Now that 2 is being multiplied, so opposite of multiplication is division. X plus 1 equals 2. Okay, so now you can see I have that radical. It's by itself. There's nothing else with it on that side. And that's the goal, is to get everything away from the radical. Now that it's by itself, I have a square root. Remember, there's like an invisible 2 here. So to cancel that out, I'm just going to square both sides. Remember before, a radical canceled out an exponent. Well, then it makes sense that an exponent should cancel out a radical. Just like plus cancels out negative, negative cancels out plus. Multiplication cancels out division, division cancels out multiplication. It always works backwards for us, which is nice. So these cancel, and I'm just left with x plus 1 equals 2 squared, or 4. Subtract 1 from both sides, and I get x equals 3. Now I do want to be careful here, because when I'm taking a square root of something, remember I can't take a square root of a negative number. So what happens sometimes with these problems is we get what we're called extraneous solutions. Typically, not always, typically this happens when you have an even root function. Remember we talked last time, even roots are those 2, 4, 6, 8, so on. In this case, a square root is an even root. And the reason for that is, again, you can't take an even root of a negative number because we get that imaginary number. So because of that, we always want to plug back in and just make sure we don't end up with a square root or a negative under the square root or under the radical for even roots. It is very, very rare, and I honestly can't think of a case where, off the top of my head at least, where you have an odd root and your solutions don't work. But it's still always good to check your answers, especially on like ACT if you have time. So plugging this 3 back in, 2 to 3 plus 1, just plugging in for x. Okay, and then the goal is to make sure that this equals 4. So I've got 2 square root of 4. And for these, we're almost always just going to take the principal square root. We're just going to take that positive square root. So 2 times 2, which is 4. Okay. So there's my solution on those. Again, these aren't too bad. I'm going to erase it. So if you need to pause it, go ahead and pause now. Okay, looking at the second one, same process. I want to get that radical by itself. I need to be careful here because this minus 1 is not under the radical. So I do need to move that over first. So 2. I'm going to add 1 to both sides. Cube root 2x minus 9 equals 3. Okay, and then I'm going to take that and I'm going to cube it, right? Because I have a cube root. If I cube it, they cancel out. But I need to cube both sides. I can't just cube 1. 2x minus 9 equals 27 plus 9 plus 9. 2x equals 36 divided by 2. Sorry, skipping a step there. Equals 18. Now again, it is good practice to go ahead and just double check that everything comes out nice for you. So cube root 2 times 18 minus 9 minus 1. So cube root, 36 minus 9. And then cube root, sorry, I was thinking ahead and thought maybe I made a mistake. Minus 1, cube root of 27 is 3, minus 1, and that gives me that 2 that I want. Okay, so again, it is good practice to go and just check all these, but really it comes down to definitely making sure you check for those even roots. And that's really it for a lot of these. Get everything away from x, or from the radical, get rid of the radical, and solve for x, and then just double check by plugging it back in. So if you have any questions on these, again, feel free to email me. I'm going to move on though, and I'm going to show you the other type that you're going to see. I'm going to go and do, actually let's do a quick word problem. So I have a word problem here, looking at the important parts. Obviously this is probably going to be important. Obviously this is probably going to be important. We're going to estimate the air pressure. Okay, well, what is the air pressure? Pressure is P. Okay, so I want to find P. Okay, and I want to find P when the wind velocity, okay, wind velocity right here, that's that VP. Okay, so I want to plug that VP in. So I'm going to say 54.5 equals 6.3, 1013 minus P. Okay, and again, just to solve this the same way. Divide by 6.3, divide by 6.3. Okay, I can't do that off the top of my head. There we go, over to Desmos real quick. So we're doing 54.5 divided by 6.3. Okay, and I get an approximate answer. So we need to be careful here, because especially with big ideas math, if I don't use everything, it may not work out nicely for me. So honestly, it's better to leave it like this. If it gave me a nice number, yay. It's not. So let's just leave it like that because it's gonna work out nicer for me in the long run when I talk about rounding. And the reason for that is if you round it now and then you have to round again later, you're getting a rounded answer of a rounded answer, and that's not good. So then square root of 10,013 minus P. I'm going to square both sides. Again, I'm just leaving it like this. It's not a big deal. Don't forget about the fraction. It's fine. So 54.5 over 6.3 squared. 10,013 minus P. I need to move this over. That's 10,013. Okay, rewriting it up here. So I've got 54.5. And again, you're not going to have to do this. Desmos is going to do the work for you here in a second. Okay, minus 13. Now this is equal to negative p. Okay, so I need to divide this. Remember, there's like an invisible 1 there. So I need to divide it by negative 1. Okay, now this looks gross, but again, I can type this directly as like it is into Desmos. So let's do that. We're going to put big parentheses around the top so it keeps everything together. Little parentheses, little parentheses around the 54.5 divided by 6.3. Here. We're going to square that. We're going to subtract that 10, 13 from that. And we are going to divide by negative 1. Okay. If you notice, if you don't divide by that negative 1, you get that negative answer. Negative pressure doesn't usually make a lot of sense.
Faculty and staff, in approximately 5 minutes in the auditorium, we will be doing our Friday open forum Q&A session. It will only last approximately 40 to 45 minutes, as I will need to head out to the volleyball state semifinals. Once again, if you have questions about the pandemic, or if you have questions or concerns about the transition to virtual instruction, please come down to the auditorium, and we will do the very best we can to answer any questions that you may have. Thank you, and we'll see you in approximately 5 minutes.
Sorry about that, guys. Okay, so we end up with 938, and we have a decimal, so we need to check and see what it's asking for. It's not asking for a specific decimal, so typically we want to assume 2. So I'm going to go 1/6, and then I don't round up, so it's going to be 938.16. Okay, and pressure is answered in millibars, so millibars. Okay. So the nice thing about these word problems is a lot of times you really have the equation, and the worst thing you have to do is to plug that in and make sure you're just plugging it in the right spot. Okay, the other, we'll skip that one. The other type of problem you might see is like number 6 here, or number 5. So for number 5, if you notice, we already have the radical isolated, which is nice. But on the other side, we have x plus 3. Now, I need to be careful here. I am going to square, and I am going to square. These are going to cancel, so I just get that 10x plus 9. That's nice for us. Okay, but here, I need to be careful. I can't just bring that squared inside. Remember, if you have addition, you cannot bring an exponent inside. It does not distribute over addition or subtraction. So that being said, I need to do x plus 3 times x plus 3. Okay, putting that in the box. x3, x squared, 3x, 9. So I have 10x plus 9 equals x squared plus 6x, coming from the 2 side boxes, plus 9. Okay, we're going to move things to one side, because we want to try to get this equal to 0 now, because I have a square. So I'm going to do minus 10x, minus 9, minus 9. Oh, that's kind of nice. Those cancel. So I have 0 equals x squared minus 4x. Okay, now I can do quadratic formula. It's going to be faster to factor here. So I want to say 0 is equal to x minus 4. Okay, using the 0 product property, I can say that my x's are equal to 0 and positive 4. Okay, now, if you ever get 2 answers, 100% double check that your answers work nicely, because this is the most common place that you're going to have an extraneous solution. So I plug that 0 back in, and really, again, I only really need to look right here. That's the important part. So I plug that 0 back in, I get 0 equals, because 10 times 0 is 0 plus 9. So I've got the square root of 9 equals 0 plus 3. Well, that's just 3 equals 3. That is a true statement, so that's good. Okay. For the other one, 10 times 4 plus 9, which is going to be square root of 49, is equal to 4 plus 3, which is that would be 7, and that is also a true statement. So both of these worked out nicely for me. So I have 2 answers here. Again, just double check on that. And that typically happens again when you have one side that doesn't have a radical. Okay, now I know this one looks worse, but it's actually the easiest problems to do, and I'll show you why. So I'm going to rewrite it, 2x square root of 2x plus 5 equals the square root of x plus 7. Okay, well, you notice I have one radical on one side, one radical on the other side. Well, to get rid of that radical on the left, I just need to square it. If I do it to one side, I got to do it to the other side. Well, that's nice because that means that radical's got to go away. So for these ones are actually the easy ones because I just need to square both sides. Radicals go away, exponents go away. I've got 2x plus 5 equals x plus 7. This is a 5th, 6th grade problem at this point. Minus x, x plus 5 equals 7, minus 5, x equals 2. Okay, double checking that this works nicely for me. 2 plus 5, 2 plus 7. This is going to be the square root of 9 equals the square root of 9, which is a true statement. Okay, so again, always double check for extraneous solutions.